we always get. This is the one that we just confirmed, and they generate all the others. By the way, what? Can I factor alpha to the n here, yes or no? Yes, so I can write it as alpha to the n plus c plus dn. Example? Uh, 334 or 534 says the following: Cn equals 6Cn minus 1 minus, oh, there's a misprint here. I hope I change it later on. Minus 9Cn minus 2. C0 is 2. C1 is 21. So what happens? Characteristic equation looks like this. R squared equals 6R minus what? 9. Do you all understand how to make quadratic equation here? So the highest member gets a square, next one gets R, the lowest one gets just coefficient. And then we solve quadratic equation. R squared minus 6R plus 9 equals to 0. And then do we have a complete square? Is it obvious that this is a complete square? So what's the solution? R equals what? 3 double solution. So what is it? This derivation here confirms that we have not only 3 to the n, but n times 3 to the n. So the general solution is an or Cn. That was the name. Cn is like C times 3 to the n plus dn 3 to the n. So first one just gets 3 to the n, second one gets extra n. And then what? That makes it very nice for n equals 0, because when you put n equals 0, what will happen? 2 equals, second term disappears because of that n. So we get just c times 3 to the 0. So we immediately get that c is what? 2. And then when you plug next one, you will get c1, which is 21, equals 3c plus 3d, because n is just 1, so it's just 3d. So from here, obviously, we get c plus d is 7. So since c is 2, d is 5. So our answer is what? Cn equals 3 to the n times 2 plus 5n. All right, that's the main theory of this section. I want to show you something else here. And that's the beginning of the section if you look at the notes. But I'm going to do it a little differently. The way I wrote it in the notes has some good tricks inside. And it kind of shows you some nice machinery there and some other methodology. But it's a little long and calculationally too complicated. But if we use a little techniques from differential equations, and if you know them, then you are perfectly okay with it. If you don't, it's not too complicated to get an idea. I want to analyze the following problem. Let me show you that on the screen. This is, by the way, might be exactly the problem that we got about lines. A linear, so not quadratic, linear equation. Here's problem 531. Is different from what we studied so far in this section. It's easier and harder at the same time. Why is it easier? Because it is not of the second order. You don't have two predecessors. So here's example. So it says an equals 2an minus 1 plus n. What happens here? Do I have a recurrence relation? I do. But of which order? First or second order? How many predecessors do I have? Only one predecessor, do you agree? So that makes it even easier, because then I will immediately tell you. So if I didn't have that n, this would be very easy. So consider first. The equation an equals 2an minus 1. Is this easy? What's this? Is this geometric, basically, yes or no? If you want machinery that we just used, you can use machinery. Why? Because characteristic equation would be what? R equals 2, and you get immediately solution. And then what? Then you have that your an is what? C times 2 to the n. Do you agree with me? Or did I have IVP? Yes, I had IVP. A0 equals 3. But, by the way, what I just solved is called homogeneous equation. Why? Because except A's, there's nobody else. And that's what we had all day long. Just A's, different generations of C, A, or B, and then there's nobody else. Do I have an extra here, yes or no? Who's extra? And those equations that have extra are called non-homogeneous. So how do you solve them? The same way as in differential equations, and that is, take a general solution of the homogeneous one and get one more solution of non-general. Just guess one good solution of this non-homogeneous one, add it up, and you are done. The question is, how do you guess it? If you remember in these, we call it the UC method. And UC method says the following. What do I see here? I see n degree. So I'm guessing solution that is in the form of n of a polynomial. But since my other 0 is not appearing, so it's kind of 1, I will look at it the following way. So look at the solution non-homogeneous. And I will look in the form of the polynomial that is 1 degree higher than arbitrary polynomial of degree n. So I will look at it in the form of an. So if this is linear, I look at the arbitrary quadratic polynomial. So I look at it the following, like an squared plus bn plus c. And then what do? I just need to recover those a, b's, and c's, and when I plug it in, I get the following. An squared plus bn plus c equals 2 times a n minus 1 squared plus b times n minus 1. Did I lose my 2? Yes, I did. 2b plus 2c. And plus n. And then what do? Just combine alike terms, compare coefficients, and you will get your a, b, and c. So I get the following, an squared plus bn plus c equals n squared. I'll square this n squared minus 2n plus 1, you know that. So that will be 2an squared minus 4an plus 2a plus 2bn minus 2b plus 2c and plus n. Plus 2bn minus 2b plus 2. Looks good. So what then? Let me combine alike terms. N squared plus bn plus c equals what? 2an squared. I have a problem with this square. What do I have with n? Here they are. So what would that be? Plus 2b, what else? Minus 4a plus 1 times n. And what else? Plus 2c minus 2b and plus 2a. And then what? Let's compare coefficients with an an squared. A equals 2a. What is that telling us? A equals 0. So we didn't need a this time. What else? B equals 2b minus 4a plus 1. So a is 0. So we get what? Negative b is 1. So b is what? Negative 1. And then what? C equals 2c minus 2b. A is 0 anyway. So from here we'll get 2b equals c. So c is what? Negative 2. So what is it? C is negative 2. So we'll get that additional member. So what's that non-homogeneous part? Negative n and minus 2. And when you combine the general solution from homogeneous part and this extra shift that non-homogeneous does, we have a general solution. And then what? The only thing left as before is to see how much is C. Who determines C? A0, so what would that be? A0 is 3 equals C minus 2, because n is 0, so C equals 5. So it looks like this. 5 times 2 to the n minus n and minus 2. Here's the formula. So let's see if n equals, let's check it. When n equals 0, we get 5 minus 2, which is 3. It's always good to check calculation at the end. When n equals 1, what do we get? When n equals 1, we get, what is it? 10 minus 3, a1 is 7. Let's see here. What? 2 times 3 plus 1, which is 7. So it works the same way. So what? If you have non-homogeneous equation, then you make a general solution of homogeneous one, where that works a little simpler than quadratic recurrence relation, and then you guess one solution. This time, it's usually in the form of the polynomial. And then what? I guessed it in one level higher because there are some cases where you need an extra n on top, so that's always safer if you do it with one member higher. And then when you compare coefficients, you get your non-homogeneous solution. When you add them up, you get the general solution. Yes?
Is there other methods for going about guessing your right side?
But generally, that's what it is. How else can you guess it? Because if it's polynomial, it's probably polynomial on the left. and then just question is which degree it should be. Sometimes you try the same degree. Sometimes if you have some special solution, then for some special cases you might need the degree higher. Yes?
So find the little gap between an squared plus bn plus c equals the 2a times the n minus 1.
Here it is.
Little n minus 1.
So here it is. This is my guess of the solution. I don't know what A, B, and C, that's called undetermined coefficients.
Right.
Then I took this and plugged it into recursive relation.
Okay.
So here it is. I copied it, then 2 times, and everywhere here I plugged in n minus 1 for n and doubled it, and then plus that extra n,
Why n minus 1?
because that's what it says.
Oh, okay. Got it. Thank you.
Good? Any other questions? All right, so that was this section 5.3 is generally just machinery. As I said, I can just show you, because this is more general method, and that one is kind of, you will see this method more explained in the homework question. There is one homework question actually asking you to do problems this way. The way I did it in the notes, I actually use some recurrence formulas, and that's the one with the derivatives, and that was not complicated. And then if you use that summation and then a little trickery, you actually get the same solution, 5 times 2 to the n minus 2. But I think that this is more general method. I was hesitant to plug it in there because if people didn't have differential equations, this might be a little unjustified because I skipped little details. Why is that hodgepodge construction really giving a solution and all that? But if you had differential equations, that should make sense, absolutely, that second method as well. All right, let's take a break. We continue at 38.